Testing sound. All right. All right. Good evening, all. We'll start. If there's anyone who don't have 2020 annual paper, past paper, I will now put a link to the chat and visit that link and download the paper from there, right? If there's anyone who don't have the paper, right? If you already have 2020 past paper with you, you can present in the discussion and you can engage with the discussion, right? So give me 2 minutes. I'll first pin that link in the chat box and we will start the discussion, right? All right. Okay. So I think now you can see that link in the live chat. So if you don't have the paper, 2027 past paper with you, what you can do is you can just visit that link and download the full paper, right? Today we'll be discussing the part 1 MCQ part of 2020 past paper. Get ready. Okay. All right, let's start. So I hope all of you are ready for the discussion. Now this is the second discussion I'm conducting on past paper reviews. Last week also we had one that is on 2019 past paper, and yeah, today you are joining with the second discussion of this past paper review series, and today we are with 2020 past paper, right? Okay, let's start with the first one. First question: dimensions of Planck's constant are. Dimensions of Planck's constant are. So you know a very famous, very popular equation is there with Planck's constant, that is E equals hf. E equals hf. So using E equals hf, right? Why can't we find the dimensions of h? Dimensions of E equals dimensions of h times dimensions of f. Dimensions of energy is ml squared t minus 2. We need dimensions of h times dimensions of frequencies t minus 1, right? Dimensions of frequencies t minus 1, because frequency is number of vibrations per second. Number of vibrations per second. So that's t minus 1 over t, right? So h will be, simplify this, ml squared t minus 1. ml squared t minus 1, right? So for the first one, answer ml squared t minus 1, answer 5. For first one, answer 5. For first one, answer 5. For first one, answer 5. Right. Second one. Yeah, students, you can put any doubts or any clarifications needed to the live chat, because I'm looking at the live chat on YouTube. So you can put anything that you have to the live chat if needed. Right. Second one. So we are moving on. Second one. Figure A shows a scale of a micrometer screw gauge when the spindle and the anvil touch each other. Figure B shows the scale when a metal sphere is properly placed between the spindle and anvil. The pitch of the screw is 0.5 millimeters and the circular scale is divided into 50 equal divisions. Right. What is the correct diameter of the metal sphere? Okay. First thing is, first it's having a zero error. It's having a zero error. Right. Second one. It's having a zero error. If zero is shifted down, shifted below the center line, that's a positive zero error, right? If zero is shifted below the center line of micrometer screw gauge, that's a positive zero error, right? So this is a positive zero error. Positive zero error. Positive zero error is given by total minus coincided number of vernier scale divisions into least count, right? So now using this equation, we can first calculate this positive zero error. Positive zero error equals total number of divisions 50 minus coincided number of divisions. It's a positive zero error, sorry, yeah. It's a positive zero error. So if that's a positive zero error, that's directly coincided number of divisions. Directly the coincided number of divisions. Coincided number of vernier scale divisions into least count, right? So calculate that positive error here. Positive zero error equals coincided number of divisions 0, 1, 2, 3, right? 3 times least count of the instrument is 0.01 millimeters, right? You should know the least count of micrometer screw gauge. If there's anyone who don't know the least count of micrometer screw gauge, least count is pitch over number of vernier scale divisions. So least count is pitch here is 0.5 millimeters. Number of vernier scale divisions 50. That is 0.01 millimeters. So this is how the least count comes. So positive zero error in the instrument is 0.03 millimeters. Positive zero error in the instrument. Now from the second diagram, we can get the apparent reading. Apparent reading is the visible reading here. Visible reading of the instrument. So any reading of any instrument which uses vernier scale, is given as reading of main scale plus reading of vernier scale. Reading of main scale is completed main scale in a micrometer screw gauge, that is only the visible part of the main scale, right? We know the gap between two divisions at opposite sides of a micrometer screw gauge is 0.5 millimeters, right? So it goes as 2, 2.5, 3, 3.5. 3.5 millimeters. 3.5 millimeters plus number of coincided divisions into least count. Number of coincided divisions here 30, 31. 31, right? Yeah, 31. 31 times least count 0.01 millimeters. Right? So that is 3.5 millimeters plus here 0.31 millimeters. 0.31 millimeters, which means this is 3.81 millimeters. But this is the apparent reading now. This is the apparent reading now. We have to correct the reading. So therefore, the correct reading is, we know it has a positive zero error. For the positive zero error, we have to do a negative correction. Negative correction means we have to subtract the value, right? Subtract that value. Then 3.81 minus 0.03. That is 3.78 millimeters. So final answer 3.78 millimeters. Answer 3. For 2, answer 3. For 2, answer 3. Right? For the second one, answer 3. Moving on. Question 3. Question 3. The threshold of hearing of normal human ear is 10 to the power minus 12 ms minus 2. This corresponds to a sound intensity level of, right? This is a value you should know. This is a must know value, right? Intensity range of human ear is from 10 to the power minus 12 to 1 Wm minus 2, 1 watts per meter, right? 1 watts per square meter. And intensity level range is from 0 to 120 decibels, right? So therefore that corresponding value will be 0. If you don't know, this is how it's proved. This is how it's proved. We know beta equals 10 log base 10 I over I naught, right? I naught is threshold of threshold of hearing. I naught is threshold of hearing. That is always 10 to the power minus 12. That's a constant value. That is 10 to the power minus 12. That's a constant value. So beta equals 10 log base 10. I is 10 to the power minus 12 now. The given value is also 10 to the power minus 12. Right? And threshold of hearing is also 10 to the power minus 12. These two cancels. Beta equals 10 log base 10 1. 10 log base 10 1. Right? Base 10 1 is 0. Right? Log base 10 1 is 0. This part is 0. This part is 0. So therefore, beta is 0 decibels. Beta is 0 decibels. For 3, answer 1. For 3, answer 1. For 3, answer 1. Next one, 4. The figure shows the velocity time graph for an object moving along a straight line. What is the average velocity of object from t equals 0 to t equals 4? Right. So we know equation of average velocity is right? So equation of average velocity is this is a must know equation. Average velocity is total distance over total time. If there is velocity displacement, total displacement over total time. Average velocity is total displacement over total time. Total displacement can be found just by using the area of Vt. That's a Vt graph given. So we know area of Vt gives displacement. So find the area of VD. This is area of VD. This will be area of VD. Right. Now, average velocity. Let's say the area of VD can be written as. So I can see there are two rectangles. One is a square. Actually, two squares. Right? Two squares. 3 times 3. One is 3 times 3. The larger one. 3 times 3 plus the next one is 1 times 1. 1 times 1 over total time is 4 seconds. So V equals, this is 10 over 2.5 ms minus 1. 2.5 ms minus 1, which means answer 3. For fourth one, answer 3. An easy one. Easy one. Now we are in the 11th week before 2025 A-level exams, right? So that's why I'm conducting this past paper discussion series with reviews, because now if you are a student who are especially facing A-levels this year, now in these last weeks of time, I know you are struggling with past papers, and you are trying to do past papers, and sometimes you don't have reviews for past papers. So likewise, there are some like issues, difficulties its students are facing. So that's why I'm conducting this pre-paper discussion series to you to get an advantage, and to you to get confidence, gain confidence, and practice these questions and sit to the exam, 2025 exam, that is coming in 11 weeks of time, right? 4 is done. 5. The figure shows a thin uniform rod AB of length L and mass M. Moment of inertia of the rod about axis PQ. PQ parallel to rod. Situated at distance Y is. Right. So when it comes to moment of inertia, we can always write moment of inertia as mr squared, just mr squared, about an external axis. Now I can clearly see PQ is an external axis for rod AB. That is not an own axis. There are two types of axes when it comes to rotational motion. One is own axis and the other one is external axis. If there is a rotation about an external axis, you can always write moment of inertia as just mr squared, right? About external axis. About external axis, I is just mr squared. About external axis, I can be written as mr squared. Now this is an external axis. M is given as M. M is given as M. Right? R is Y. R is Y. Distance from axis to, see, rod is here, axis is here. Distance from axis to rod is L. Sorry, Y. Distance from axis to rod is Y. Perpendicular distance. Perpendicular distance from axis to rod is Y. Right? So therefore, times is Y square. That's it. So answer is I equals my square. My square. Answer 1. For 5, answer 1. Six. The quark content of a proton P and a neutron N are respectively given by. That's only from theories, fundamental particles, right? Quark 5, we are in question 6. So if that's a proton, that is UUD. If that's a neutron, that is UDD. Right? UUD and UDD. UUD and UDD. Answer 4. For 6, answer 4. Right? 7. Which of the following statements made regarding seismic waves is incorrect? Right. All seismic waves are mechanical waves and require a medium to propagate. Correct? All seismic waves are mechanical waves because we have P and S types. P types and S types. Right? Yeah, there are no electromagnetic seismic waves. All are mechanical waves. Primary waves are longitudinal and secondary waves are transverse. Yes, exactly. Yes. P waves. Primary waves means P waves. P waves are longitudinal. And S waves, secondary waves are transverse. Correct. The speed of S waves is less than that of P waves. Yes, higher speeds are with P waves. 4. S waves can travel through both liquid and solid media. S waves can travel through both liquid and solid media. When it comes to S waves, they only travel through solid media. P waves can travel through both liquid and solid media. That is correct. P waves can travel through both. When it comes to S waves, they can only travel through solid media, not through liquids. So therefore, 4 is incorrect. Answer 4. Totally from theories. Totally from theories. Right. 8. 8. A narrow beam of monochromatic light XY falls on a converging lens L as shown in the figure. After refraction through the lens, the beam hits the screen S and makes a light spot. What would be the position of light spot? Okay. Now this is given. 7 is done. 8. 8. Okay. This is given. See. This is called the focal plane. Focal plane. The vertical plane which goes through focal point is called the focal plane. Right? And this kind of a ray is given. Right? Now, when you try this kind of a question, what you have to do is you can use the given paper itself and do some modification here. And get the correct answer. Right? We know the light ray which goes through optical center C won't be refracted. It is not refracted. So therefore, I'm going to consider another light because that's a light beam, a narrow beam of monochromatic light. Right? I'm going to consider another ray which falls parallel to this, which goes through C. So if it goes through C, it will not be refracted. So it is going to a certain point here on the focal plane, which means if that intersects the focal plane at that particular point, all the light rays in the beam should go to the same point, right? So therefore, after the refraction, this will also be at the same point. And if I consider a light ray like this also, that will also be at the same point, right? Now you have to do that modification in the given diagram and see, right? Do that modification in the given diagram and see. And it comes to D. Right? So if you do it properly, it comes to D. D means answer 4. This is how you should do it. Consider this ray. This is very important. Huh? The light ray which goes through optical center won't be refracted. Right? So repeating again, draw another parallel ray to XY using a ruler. Draw another parallel ray to XY which goes through optical center and extend it until it intersects the focal plane. And that point it intersects the focal plane is the light spot, is where the light spot is. Right? So it's close to D. Right? You can draw it and see. Don't copy down, because if you copy it down to a separate sheet, the scale will be different. So therefore, you have to use the same paper given and do the modification, draw the modification on the paper itself. Right? 9. Positions of particles of a transverse wave traveling along plus x direction of a certain instance is shown in the figure. A pair of particles with same instantaneous velocities is, right? So if there's a displacement time graph, we all know that velocity is given by Gradient. Velocity is given by gradient. That's a displacement time graph, ST. Right? So we all know that velocity is given by the gradient. Velocity is given by the gradient. If that's the same instantaneous velocity, then their gradient should be same. That is my argument. That is my argument. Right? If I consider the gradient of a point like B, the gradient is like this. And if I consider a gradient of a point like F here, see, that is also in the same direction. These two gradients are same. If gradients are same, velocities has to be same. So answer is B and F. For 9, B and F. B and F. Answer 1. Right? B and F. Answer 1. For 9, answer 1. 10. A small instrument of mass 1 kilogram is placed on a planet. The mass of planet is 3 times and radius is 2 times that of Earth. What would be the weight of the instrument on the surface of the planet? Neglect all other effects except gravitation. Okay. So we all know that gravitational field intensity, G dash, gravitational field intensity, G dash is given by GMOR squared. GMOR squared. Now, if there is at Earth surface, right, this is for Earth surface, we know G equals GMOR squared. And G is 10 as a value. G is 10 as a value. So, which means 10 equals GM over R squared, right? And we can apply the same equation for planet P, for planet, right? And what is asked? Weight, right? What would be the weight? Yes. Then if G dash is known, which means weight is known, right? So if G dash of the planet is G, now instead of M, it says mass of the planet is 3 times, and the radius is 2 times. Then this is 3m. Radius is 2 times, 2r whole thing is squared. G dash equals G, let me put this 3 here, M over, this is 4r squared, 4r squared. But we know GMO r squared is 10. From above, GMO r squared is 10. So which means G dash equals 3 over 4 times 10. 3 over 4 times 10. 30 over 4. 30 over 4 means 7.5. Oh, it's not simplified. This is 30 over 4. 30 over 4 means this is 15 over 2. ms minus 2. Now, if the weight is needed, that's a 1 kilogram. So, it will be same because mg, m is given as 1 mg. So, weight is, see, weight will be mg dash. So, weight is m is 1, g dash is there, 15.2. So, that weight is 15 over 2 newtons. Very simple, 15 over 2 newtons. For 10, answer 3. For 10, answer 3. For 10, answer 3. 11. 11. 11. Two identical transverse waves of frequency 300 Hz and speed 30 ms minus 1 traveling in opposite directions along x-axis superimpose with each other and produce a standing wave. The distance between a node and its adjacent antinode is equal to. The distance between node and its adjacent antinode is equal to node and adjacent antinode, which means we are asked about lambda over 4, because two waves are traveling like this. Look at here, 11. Two waves are superimposed, right? So it should be something like this. So like this, two waves are traveled. And so we know here we have nodes and this is antinodes. Distance between node and antinode, one loop is lambda over 2. In a stationary wave, one loop is lambda over 2. So which means this part has to be lambda over 4. If lambda is known, which means lambda over O can be determined. Lambda over 4 can be determined. Apply V equals F lambda. V is given 300. 300. F. Oh, sorry. V is not given. V is not given. V is given 30. V is given 30. 30. And F is 300 times lambda. So which means lambda equals, this is 30 times 10, right? Lambda equals 0.1 meters, which means lambda equals 10 centimeters. 10 centimeters. If lambda equals 10 centimeters, therefore lambda of 4 equals 2.5 centimeters. 2.5 centimeters. Answer 1. For 11, answer 1. Right? So that is just a matter of identifying the wave. Just a matter of identifying the wave. Identify the stationary wave. Identify the given stationary wave. That's it. So, 12. Very long 8 parallel wires. Each carries a current of 10 amperes. The directions of current in each wire are shown in the figure. The magnitude and the direction of magnetic flux density produced at the center CR. mu naught of O is given 10 to the minus 7. Neglect the effect of Earth's magnetic field. Okay. Now it's like this. See, there are 8 wires given. 1, 2, 3, 4, 5, 6, 7, 8. And point C is here. Right? And their current directions are cross, 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 dot, cross, cross, dot, and dot. Right. So we know direction of magnetic flux density is given by right hand rule. Direction of magnetic flux density is given by right hand rule. Right? To get here. To get here. Now, if I apply right hand rule for one wire like this, let's say for the cross one, see, direction of current flow at C is, see, this is along the tangent. Now, this is a circular direction, circular electric field, magnetic field is like this. Now, this has a magnetic field in this direction around the wire. This has a magnetic field in this direction around the wire, right? Then if I need the magnetic field here, that should be along that tangent. That should be along the tangent. So therefore, if I consider that magnetic field here, it will be like this, B. And if I consider the magnetic field from this cross one here at the top, it goes to the upward direction like this. That is also same in magnitude. Same in magnitude because currents are same and distances are same. Equation of magnetic flux density from a wire is B equals mu naught of 4 phi 2I over R. This is the equation. This is anyway a constant. Mu naught of 4 phi is a constant. If currents are same and if distances are same, which means magnetic flux densities are also same. Now these two are equal and opposite, so it cancels each other. It cancels each other. Similarly, these two also cancels. These two also cancels. Can you see? So therefore, now the question is becoming very easy. See, question is becoming very easy. These two cancels, right? So likewise, if you have conducting wires which carries the same current at a same distance, their magnetic fields, magnetic flux densities, magnetic field intensities cancel each other. So therefore, this to this cancels. This one to this one cancels. This one to this one cancels. Only these two remains. Only these two remains. Now by this cross one, you can see it's downwards. See, B is downwards. Right? With this dot one, B is also downwards. So therefore, it is downwards to B. it's downwards 2b, right? And b is given by this. It's downwards 2b. b is given by this, right? Mu naught of 4 pi, 10 to the power minus 7. 10 to the power minus 7. 2 times I is 10 over r. R is given. What's the distance here? 10 centimeters. 10. 10 times 10 to the power minus 2. These two cancels, right? Which means this is b, this times 2. This times 2. Right? 2b. We need 2b. This part is a b. This part is a b. Okay, simplify this. 2 times 2, 4. Right? 2 times 2, 4. Times 10 to the power minus 5. This is in this standard unit. Right? Tesla. Now, if I need to make this micro Tesla, micro means 10 to the power minus 6. So, multiply this with 10 to the power 6 micro Tesla, which means final answer 40 micro Tesla. And direction is, you can see it here, downwards. And this direction is downwards. 40 downwards, answer 4. For 12, answer 4. That's a good question. First remove the wires which are cancelling each other and simplify the remainings. Right? 12, answer 4. 13. 2 adjacent rooms A and B. 2 adjacent rooms A and B at same temperature connected by a closed door are initially at relative humidity are at 60 and 90 respectively. 2 adjacent rooms A and B. See, 13. 2 adjacent rooms A and B. A and B connected by a closed door are initially at relative humidity 60 and 90. Right? Then here relative humidity is 60% and here that is 90%. 90% initially. The volume of room A is twice that of room B. Right? Which means if this is V, this volume is 2V. If the door is kept open for a long time at the same temperature, if temperature remains constant, saturated values are not going to change. Saturated values will remain same. What would be the final relative humidity of rooms? Okay, now considering initial scenario, let's write something like this. If volumes are given in a humidity question, the easiest approach is using density equation. Density of absolute humidity we call absolute humidity equation. So therefore, I will consider the masses of water vapor inside these rooms as Ma and Mb. Right? Let's consider mass of water vapor inside this room as Ma, mass of water vapor inside that room as Mb. Right? So we know this equation. Y can be written as rho over rho naught times 100%. Y can be written as rho over rho naught times 100%. So you can use this equation for A and B separately. For A and B separately. Right? See, for room A, 60 equals rho is MOV, density is MOV, rho is MOV. That should be MA over 2V over rho naught times 100%. For room B, 90 equals MBOV over rho naught times 100%. Right? Now, if I use this for the final room, final system, then final system, Y equals, now mass should be the addition because if the door is open, if the door is open, now it works as a single room. It works as a single room. Now, in that single room, total mass of water vapor is Ma plus Mb. Right? Total mass of water vapor is Ma plus Mb. Total volume is 2V plus V, 3V over same rho naught because temperature is same. Temperature is same times 100%. Right. Now, I can get two answers for Ma and Mb from these two equations. So, I'm going to get Ma and Mb from these two and plug that value here. See, Y can be written as, right, This is 1 over 3V rho naught times, for MA, you can write 60 rho naught. See, for MA, 60 rho naught times 2V over 100, right? MA is this MA, 60 rho naught 2V over 100. Similarly, MB is 90 rho naught V over 100 times 100%. Now what I did was, this is MA. This is MA from above equation. This is MA from this equation. And this is MB from this equation. Simplify this. Simplify this. V rho naught to V rho naught to V rho naught cancels. And 100 to 100 to 100 cancels. Okay, now what's remaining? What's remaining is y equals, this is 1 over 3 here, and 60 times 2, 120 plus 90 here, right? 120 plus 90 means 210. So which means is 210 over 3, that is 70%. So final answer 70%. 70% answer 2. For 13, answer 2. For 13, answer 2. 70%. Right. Next. Fourteen. All batteries shown in the circuit diagram have negligible internal resistance. If the capacitor C is ideal, what is the potential difference across C? Okay. Now this is the given circuit. This is the given circuit. 3 volts C capacitor, 2 volts, 3 ohms, 3 ohms, 2 volts, 3 volts C, 6 volts, 5 ohms. Right. So we know there are no direct current flows through capacitors. There are no direct current flows through capacitors. So therefore, the current in the circuit flows around this loop. Highest battery is here, 6 volts. So therefore, let's say the current flows out from that, and there is no current through this branch because capacitors are there. There are no direct current flows through capacitors. Right? I. So this is how I flows. Right? First, I'm going to determine that I by using Kirchhoff's laws for this loop here. Right? See, for that loop, sigma equals sigma here. Sigma is 6 minus 2. 6 minus 2. Same I flows through 5 plus 3, right? No internal resistance. Yeah. 5 plus 3. So this is 4. 4 equals 8 I, which means I equals 0.5 amperes. I equals 0.5 amperes. What we need is, what is the potential difference across capacitor? Okay, if we need potential difference across capacitor, start writing potential difference at one end and reach the other end. So let me label this as A and B. A and B. So let's start writing potential difference from A. This is how the potential difference along the circuit is written, starting from A, VA. Right? When we cross the battery to the same direction of arrow plus 3, and when we are coming to here, we have to cross the battery to the opposite direction of arrow minus 2, and to the same direction of current flow minus IR. Potential drop, potential absorption, no, potential drop by the resistor is minus IR. So that is minus I is 0.5, R is 3. Now we add point B. Simplify this. VA plus 3 minus 2 means plus 1. And this is minus 1.5, which means this is minus 0.5. Right? minus 0.5 equals VB. Then VA minus VB equals 0.5 volts. Potential difference across the capacitor is 0.5. For 14, answer 1. For 14, answer 1. Answer 1. Right. 15. 15. Okay. Which of the following statement is incorrect? Which of the following statement is incorrect? The electrical conductivity of an intrinsic semiconductor increases with increasing temperature. Correct. What is the variation? We draw it in current electricity. Right? For semiconductors, statements are 1, 2, 3, 4, 5. Right? For this, we draw this kind of a variation. For rho and R, with temperature. Rho and R with temperature. For semiconductor materials, what happens is its variation is like this. When temperature increases, resistance and resistivity slightly decreases. Right? We know resistance and I are two inverse things. Higher the resistance, lower the current. Now, when resistance is higher, I increases. I increases means conductivity increases. So 1 is correct. 1 is correct. Second one. A full wave rectifier cannot produce a constant DC output voltage for a sinusoidal input. No, it works for a sinusoidal input because rectifiers are used to convert AC to DC, alternative currents to direct currents. Alternative current is like this, sinusoidal. Alternative currents are like this, AC. ACs are like this, right? And the converted DC will be like this, right? So it can be converted. A full wave rectifier, a full wave rectifier cannot produce a constant DC output for voltage of a sinusoidal input. It's asked about this. Now, if you know output of this, look at here, this is not the case. If you know, look at here, if you know the output voltage variation of the rectifier circuit, see, V out of the rectifier circuit, the exact output is like this. Exact output is like this. This will be the output. This is the shape. So therefore, there is not a constant value. It is having some ups and downs. Therefore, that is correct. Right? Constant in the sense that is not exactly constant. Even though it's a DC, it has some unevenness, ups and downs. Right? So is correct. Third one. In a bipolar transistor, the emitter is heavily doped than that of the collector. Correct. Because why? IE equals IC plus IB. Right? So highest current is at IE. To carry highest current, it should be highly doped. 3 is correct. 4. Drain current, ID of a junction field with transistor is maximum when gate to source voltage is 0. When VGS is 0. Correct. Drain current, ID of a junction field effect transistor is maximum. Yes, because see, the equation is VGS equals minus IDRS. So therefore, higher the VGS, lower ID, because there is a plus and minus variation. No? Higher VGS means lower ID, right? So VGS and ID are inverse. So therefore, to get the maximum ID, that is when gate is set to VGS 0. Yes, that is when this is set to VGS 0. Correct. Because when this is 0, this will be maximized. 5. When an op-amp is used as a voltage comparator, closed loop state is used. No. In voltage comparators, we use open loop. In voltage comparators, we use open loop. Open loop is used. Open loop is used. So that is answer 5 for 15. Answer 5 for 15. Incorrect one is 5. 5 for 15. Right? Next. So if you don't know the voltage comparator circuit, it is basically like this. Voltage comparators. V out is taken from here. V out is taken from here. Right? This is the basic voltage comparator circuit. Right? Like V1, V2, like V3, ground, like this. This is a voltage comparator, open loop. If output is not connected back to input terminals, that is called an open loop. If output is connected back to one of the input terminals, that is called a closed loop. This is an open loop. 16. A particle of mass m performs a simple harmonic motion if the maximum velocity and the maximum acceleration of the particle are v and a respectively. The angular frequency omega of the particle is given by. Okay. Look at here. We know the general equation of a simple harmonic motion is a equals minus omega squared x. No, a equals minus omega squared x. Minus sign refers to the opposite directions of displacement and acceleration, because in a simple harmonic motion, acceleration is always towards the center, whereas the displacement is measured from the center. So therefore, they are two different directions. They are two different directions. Since they are two different directions, a minus sign is put. Now, if we just need to consider the value here, you can neglect the minus sign and do the calculation as well. Right? Maximum A is given. Maximum acceleration is A and maximum velocity is V. Right? So you know maximum acceleration occurs at amplitude. Maximum acceleration is at amplitude. See, since maximum A is at amplitude, so we know amplitude means that is the point where x equals A. That is the point where x equals A. Right? So therefore, from equation 1, I can get A equals omega squared A. A equals omega squared A. Let's say 1. Right? And maximum velocity is also given. Maximum velocity, we know that's a proved equation. Maximum velocity of a simple harmonic motion is given by A omega. Right? Maximum velocity, U max, is given by A omega. U max is given by A omega. Now U max is given as V, which means V equals A omega. Right? What we need? We need omega. We need omega. Then easily I can plug something for A using equation 1. Look at here. V equals, for A I can use A over omega squared. For A we can use A over omega squared from equation 1. Right? A over omega squared times omega. 1 omega to omega cancels. So omega equals A over V. Omega equals A over V. Answer 4. For 16, answer 4. Answer 4. Right? If you understood the question properly and if you know simple harmonic motion equations, that's a very easy one. Very easy one. Next, 17. The length of the potentiometer via AB is 600 centimeters and its resistance is 10 ohms. R is a resistance box. When R is set to 70 ohms, the balance length is 280 centimeters. What will be the distance that sliding key J must be moved from the previous position to balance again if R is changed to 80? Right. So we know at the balance point of a potentiometer, there is no current flows through galvanometer. There's no current flows through galvanometer. So therefore, in the above loop, a separate current flows. Right. Considering that, I'm going to use potential divider and get the potential difference across potentiometer via AB first. Right. This is the potential divider if you don't know. 17. Say potential divider means if you have two resistors in series combination. If you have two resistors in series combination with a voltage difference, total voltage difference, we across them, potential across R1 can be written as, let's say V1 can be written as V over R1 plus R2 times R1. And if you need potential difference across R2, it can be written as V over R1 plus R2 times R2. This is called the voltage divider or potential divider. I'm going to use this and get the total potential difference across potentiometer via first, right? Because potentiometer via is also a resistance. That's a resistor that is given as 10 ohms. And R is also a resistor, and R and potentiometer via are two resistors which are in series combination. So therefore, we can use potential divider. Let's say VAB, right? Potential difference across the potentiometer via VAB. If there is VAB can be written as total potential difference of the above loop is E naught over addition of resistance 10 plus 70 plus 10 times, if I need the potential difference across potentiometer wire, multiply it with the resistance of potentiometer wire 10. See, so VAB is 0 to 0 to 0 cancels. E naught over 8. VAB is E naught over 8. So we know principle of a potentiometer is VAC equals KL. VAC means the balance length. Potential difference across the balance length. VAC can be written as KL. In a potentiometer, see, VAC can be written as KL. Right? C is the balance point. Then potential difference up to balance point. Right? Now from the below circuit you can see potential difference across the balance length has to be E, because a battery E is connected below. If there is no current flows through that battery, the potential difference across the wire is equal to potential difference of the battery. So this is E. This is E. And K is, what is K of a potentiometer? K of a potentiometer is voltage drop per unit length. And that is VAB over LAB. Total potential difference over total length of the wire. Right? So therefore, this K can be written as total potential difference is known now. E naught over 8. And total length of the wire is 600. That's given 600. And this is actually LAC, balance length. Balance length is given 280. Okay. From here, I can get something like this. This is E naught over 8 times 600 times 280. I'll keep as it is and then going to move on to the second scenario. Right? In the second scenario, we can determine VAB again. Still, the total is E naught. Right? And if that R is changed to 80, if R is changed to 80, this will be 80 plus 10 times 10. 0 to 0 to 0 cancels. New VAB is E naught over 9. 8 plus 1, 9. New VAB is E naught over 9. Then for the second scenario, new VAC will be again K, this is K1, let's say K1. This is K2 LAC. Right? This is VAB1 and VAB2. They are different because K changes. When this changes, K changes. Right? So this can be written as, now still the battery connected in the below circuit remains same, which means VAC remains same. E. same E, and K can be written as E naught over 9 over 600 into balance length, let's say L. So which means from here E equals E naught over 9 times 600 times L, right? Let's say this is equation 1, this is equation 2. These two are equal. So I'm going to equate these two. Look at here. You can equate these two. You can equate these two. 1 equals 2. Right? 1 equals 2. From here, E naught over 8 times 600 times 280 equals E naught over 9 times 600 times L. E naught to E naught cancels, 600 to 600 cancels, right? So L is, you can see 9 times 280 over 8. Okay. By 4, this is simplifiable. This is 4 times 2. This is 4 times 70. 70 over 2 is 35. 35. Which means L is 35 times 9. 35 times 9 means 315, right? 315. So new length is 315 centimeters. Then what is asked? The distance must be moved. So the distance moved is, therefore, D is 315 minus 280. That is 35 centimeters. 35 centimeters. 35, answer 3. For 17, answer 3. For 17, answer 3. That's a good calculation. That's a good calculation. 18. 18. Okay, 18. Logical inputs A, B, and C of the given circuit is shown below. Okay, input signals of ABC are given. The shape of the correct output X is, right. First, write down X using the given circuit. See, the given circuit is this. And get here, and it is connected to an OR gate here, and output is taken, not F, that is X. Output is taken X, right? A, B, C, right? Function of a NOT gate is, function of an AND gate is dot. So which means after this A dot B comes, because up to here A comes, up to here B comes, after this A dot B comes. So A dot B comes up to here, and this is C. Function here of the OR gate is plus, which means X equals, from here A dot B comes, A dot B plus C, right? Now, if the output is known, if the output signal variation is known, output signal is known, apply the values of A, B, C for some time intervals and check answers. Now, as an example, let's check for the first time interval. In the first time interval, A equals 0, B equals 0, C equals 0, right? 0.0 is 0, plus 0 is 0, X should be 0, right? X should be 0. In all answers, there is 0. Check the second time interval. In second time interval, A equals 1, B equals 0, then 1.0 is 0, and C equals 1, then plus 1 means 1. Answer is 1, right? Then second again 1 went down, which means 2 is a possible answer, 4 is a possible answer. Now all other answers are removed, because in the second time interval, output should be 1. All other answers are removed. 2 and 4 remains, right? And since in the third time interval, both are 0 in both 2 and 4, I'm going to check the fifth time interval. Fourth time interval. Let's check the fourth. In fourth time interval, A equals 1, B equals 1, C equals 0. if A equals 1 and B equals 1, 1 plus 1 is 1, right? If there is 1, 1 plus anything is 1, so x will be 1. Since x is 1, x is not 0, that is not 4 then, answer will be 2, right? Answer is 2. So after getting this, just plug 1 and 0 values for a few time intervals and see. Very easy. Second one, answer is second one, 18, answer 2. 19. 19. The combined object illustrated in the figure is formed by joining four metallic rings A, B, C, and D of radii R, 2R, 2R, and 3R respectively, made out of the same uniform wire. The distance to the center of gravity of combined object from point X is, right? Look at here, that's a good calculation. See, that is going to be a good calculation. 3R, right? See, this is with 3R, and inside we have 2R and R, 2R and R, 2R and R, and here also we have another 2R. Here also we have another 2R. See, look at here. Right. Now you can see from A, B, C, D, from A, B, C, D, we know B and C are same in size. B and C are same. Since B and C are same, I know center of gravity of B and C should be at their center. So that I can see first. So therefore, I'm going to isolate these four rings as B and C together and D and A together, right? Look at here. So we know when dealing with rings, when you write volume, when you write weight, if you need to write mass, you need to write volumes. When you are writing volumes, we are using lengths of them. Since they are wires, there's no volume, just the length is there, so we'll be writing lengths, right? So therefore, now here the length is, we know this radius is 2R. This is 2 phi times 2R rho g. So weight is, this is how it is written now. This is how it is written. If you don't know, we know m equals v rho, mg known, mg equals v rho g. And instead of v, we are writing lengths. Right? And here also, that will be same. Here also, that will be same. 2 phi times 2R rho g. Which means resultant of these two has to be at the center of them, because they are two equal forces, two equal weights, 4 phi r rho g, 4 phi r rho g. So resultant of those two is 8 phi r rho g, that should be at here, right? That is 8 phi r rho g, that is at here. This is the resultant of these two, right? And about the remaining two, we know from here the weight axis 2 phi r rho g, and from the length 2r, the weight axis 3r, from the length 3r, radius 3r, the weight axis 2 phi 3r rho g, right? And resultant of these two will be somewhere in between this line. It should be somewhere in between this line, and we know this value is r. And from this center to this center also, that is also r. This part is also r, right? And this part is 2r, its radius. This one's radius is 2r, and this one's radius is 3r and 3r, correct? Right. 2r again, this is also r, this is 2r. So this is how the lengths are, right? Now, the resultant of these two has to be somewhere in that line, right? So let me consider it as here. Let me consider it as here. So you can see from here there is a 6πr rho g, 6πr rho g, and this is 2πr rho g, which means here it should be 8πr rho g as the resultant, 8πr rho g. So we know force dividing ratios. Look at here. Force dividing ratios is the easiest way to solve center of gravity questions. Force dividing ratios. Now, if you don't know force dividing ratios, this is what force dividing ratios are. If we have two forces, as let's say F1 and F2, right, separated with a distance L, separated with a distance L, the distance to resultant point F1 plus F2 can be written as, let's say, A, G and B. AG can be written as total distance over addition of forces F1 plus F2 resultant times, if I need AG, multiply it with F2, right? And if you need BG, L over F1 plus F2. If you need BG this side, multiply it with F1, right? This is called force dividing ratios. Now I'm going to use force dividing ratios here to determine this value. Now let's say center of gravity of these two is G1. Let's say that is G1. G1 is here, right? And let's say this point is O. I need OG1. If I need OG1, see, this is how force dividing ratios are applied. OG1, total distance between O and this force is, total distance is 2R. And addition of forces, I have already added them. There is 8πr rho g. 8πr rho g times, if I need OG1, multiply it with the other one, 6πr rho g. 6πr rho g. See how it cancels? Πr rho g to πr rho g cancels, right? And 2 times 3, 2 times 4, right? Which means OG1 equals 2 and 4 also cancels, right? That is 3R over 2. That is 3R over 2, right? That is 3R over 2, OG1. OG1 is 3R over 2, which means this distance is known now. This is known as 3R over 2. Okay. And we know this force is now, right here, this force is not simplified yet. That is also 8πr rho g. That is also 8πr rho g. And this one was also 8πr rho g. Now, simply, if these two are two same magnitudes, their resultant has to be at the exact same point in between. Now, we know total can be written as, from this point, let's say this is G2, right? Total distance between G1 and G2 is known now. If total distance between G1 and G2 is known, since these two forces are equal, their resultant is coming exactly in between those two forces, right? So therefore, now distance to the center of gravity has to be the exact midpoint, center point of G1 and G2. See, so the center of gravity should be at the middle point of G1 and G2. First, let's see what G1, G2 is. G1, G2 can be written as OG1 plus R, R plus OG1. R plus, because this part is R, this part is R, this is OG1, R plus OG1. So R plus OG1 is 3R over 2. Right, common denominator is 2 into, this is 2R plus 3R, which means there is 5R over 2. Right, so therefore, distance to this center of gravity is now, this is where the total force acts. 8π means there is 16πr rho g. 16πr rho g acts here. That should be at the exact middle point of the G1, G2, right? So therefore, the final answer, center of gravity has to be at the middle point, half times G1, G2, which means there is, if there is 5R over 2, that has to be 5R over 4. That's a good question. 5R over 4. Answer is at 2. 5R over 4. 19, answer 2. For 19, answer 2. $20. Water and coconut oil are poured into the two limbs of U-tube as shown in the figure. Assume that the water oil interface is at the middle of the tube and it is vertical. Rho W density of water, rho naught density of coconut oil, rho O density of coconut oil. Consider the following expressions about the situation. Okay, 20. Okay, it's like this. Here we have water at this side. At this side you have water, and at that side this is coconut oil. This is coconut oil, right? This level is given. This level is given, right? So we know this is where the interface is. This is where the interface is. This is where the interface is. Interface, right? First one, pressure at point P equals pressure at point Q. Yeah, P and Q are here. P and Q are here. Yes, because pressures at the same level of a static liquid, same static liquid is same, right? So therefore, pressure at P equals pressure at Q, because that's actually the same point actually. Same point from either sides, P and Q. That is same. If the interface is at equilibrium, pressures from both sides should be same. If the interface is at equilibrium. So therefore, very straightforward, pressure at P equals pressure at Q equals pressure at P equals pressure at Q. Correct. Pressure at P equals pressure at Q, correct. B, H1 rho W equals H2 rho O. Okay, you can see 2A, H1 and H2 are marked, right? These two, H1, H2, right? At the same interface, at the same level, pressures of the static liquid will be same. Now, if these two are same, along this line also pressures are same. Along the line also pressures are same. So you can start writing pressures from the top. That is correct. This is open to atmosphere, P naught. This is also open to atmosphere, P naught. So pressure at this level can be written as, see, pressure at this level can be written as P naught plus H1 rho WG. And from the other side, it can be written as P naught plus H2 rho OG. H2 rho OG. P naught to P naught cancels. And then G to G cancels. H1 rho W equals H2 rho O. Correct. Correct. See, H3 rho W equals H4 rho 4. H3, here. Up to somewhere here. No. Even though it's the same level, same horizontal level, if they are two different liquids, pressures are not going to be equal. Right? For two different liquids, that is not going to be equal. Now, at this level, that is equal because the equilibrium is kept by the interface. But here, there is no interface. If there is no interface in two different liquids, even though that's the same level, pressures are different. Right? Pressures are different. That is wrong. So, therefore, only A and B. Only A and B are true. Answer 3. For 20, answer 3. For 20, answer 3. Right. $21. Two identical open pipes, each of length 50 centimeters, are sounded with their fundamental notes at 15 degrees Celsius. The variation of velocity of sound V ms minus 1 in air with temperature is given by V equals, an equation is given 331 plus 0.6 theta, where theta is in degrees Celsius. if the temperature of one pipe is raised to 30 degrees Celsius, what would be the number of beats produced per second? Number of beats is the difference between frequencies, difference of two frequencies, right? Okay, now first of all, I'm going to check these velocities at these two. Look at here. Now we know V is given by 331 plus 0.6 theta, right? So therefore, first we can get these velocities at 15 and at 30, right? At 15, let's say V15 will be 331 plus 0.6 into 15. So that is 331 plus, this is 9. So V15 is 340. And velocity at 30 will be 331 plus 0.6 times 30. That will be 331 plus 18, right? Yeah, 18. That is 349 ms minus 1. 31, 41, right? 349. Now, if velocities are known, two tubes, two identical open pipes. We know in an open pipe, the fundamental frequency is this. It says fundamental frequency is this. So where if this is 50 centimeters, so we know this is one half of a loop. Half of a loop is lambda of 4. So which means lambda of 4 times 2 here equals 50, right? So which means 2 to 4 cancels, lambda equals 100 centimeters, meaning lambda is 1 meter. Right. Now lambda is also known. If lambda is known, to get frequencies, apply V equals F lambda. Right? See, using V equals F lambda. Again, at 15. Right? At 15, we know V15 is 340. V15 is 340 equals, I need F1. Let's say F1, lambda is 1. So which means F1 equals 340 hertz. And similarly, at 30 degrees Celsius, 349 equals F2. Lambda is same because same tube is used. Same tube, same fundamental frequency. So therefore, F2 is 349 hertz. Number of beats means difference in frequencies. See, very easy. So number of beats, delta F, is F2 minus F1. 349 minus 340, 9 hertz. 9 hertz, number of beats 9. For 21, answer 3. For 21, answer 3. Twenty-two. Two blocks A and B of mass 0.5 kilograms and 1 kilograms respectively are connected by a massless inextensible string which goes over massless smooth pulley as shown in the figure. The coefficient of dynamic friction between all contact surfaces is 0.25. What is the force F needed to drag the block B to the left with a constant speed? Okay. Relative motion in friction. Relative motion in friction. Okay. This is given. This is force F. Right? So we know friction is a force. Friction is a force which exerts A and B. We know friction is a force which exerts to opposite direction of motion or opposite direction of moving tendency. Right? Now here we can see the motion is going to be to the left. So therefore, friction at this surface is, let's say F1, that is opposite. right? On the same object, friction will be acting to the same direction. So therefore, here there will be another friction, let's say F2, and equal and opposite friction of that is on A, F2 again. And this is a string, so a tension for the string is there. These are the forces, right? Now first we can determine F1 and F2. We can determine F1 and F2. F1 equals, we know F equals mu R. See, F equals mu R. You know F equals mu R. If you need F1, F1 can be written as coefficient of friction is 0.25 for any surface. 0.25 again 104 for F1. For this surface, total weight tax, total mass is 1 kilogram plus 0.5 kilograms, 1.5 kilograms. So therefore, at this surface, the reaction will be 15 newtons. At this surface, reaction will be, right, 15 newtons into 15. So F1 is 1504 newtons. And if I need F2, F2 will be mu times R. For this surface, reaction is just by 0.5. 0.5 means that is 5 newtons. 5 newtons. Right? 5, which means F2 is 5 over 4 newtons. Right. So we know if this is moving with a uniform velocity, B also moves. B moves with a uniform velocity, so A also moves with a uniform velocity. If there is moving with uniform velocities, forces are in equilibrium because no unbalanced force. Uniform velocity means acceleration is 0. If acceleration is 0, no unbalanced force. Forces are in equilibrium. So considering A, you can say that is in equilibrium. F2 equals T. So which means T is also equal to F2, 5 over 4 newtons. And now considering B, we can say that is also in equilibrium. To the left, we have F. To the right, there are 3 forces, F1 plus, F2 plus T. So F equals F1, 15 over 4, plus F2, 5 over 4, plus T is also 5 over 4. So final answer is 5 plus 20, 25. 25 over 4. 25 over 4 means 6.25. 6.25 newtons. 6.25. Answer 4. For 22, answer 4. Right? For 21, I mentioned that for 21, answer 3. For 21, answer 3. For 22, answer 4. 22, answer 4. 23. A projectile suddenly explodes into 2 fragments with equal masses at the highest point P of its trajectory. If one fragment falls vertically downwards with an initial velocity as shown, which of the following diagrams best represent the path of other fragments? Neglect the R resistance. The broken line represents the path of the projectile if there was no explosion. Right. 23. Okay, it explodes at the maximum point. So we know at the maximum point, there is only a horizontal velocity remains. For a projection, right? Now, direction of initial linear momentum is only horizontal. There is no vertical linear momentum, right? Initially, there is no vertical linear momentum initially, right? Now, if there is broken to 2 parts and it says one part travels downwards, one part travels downwards. If there is no vertical linear momentum initially, 0, finally also it has to be 0 according to law of conservation of linear momentum, right? If there is no initial vertical linear momentum, then finally also there shouldn't be a vertical linear momentum, right? So therefore, to cancel it off, one component of velocity should be acting here of the second part of the particle, and They are equal sizes, right? Into two axial with equal masses. Yeah. Then if they are equal masses, let's say this is m, this is m over 2. This is also m over 2. Then if this velocity is u, this should also be same as u. That should also be same as u. Right. Now initial linear momentum horizontally, it had was mv. Initial one was mv. Now finally, if I consider the horizontal direction, right? If I consider the horizontal direction, now horizontally m over 2 moves with x, right? Let's say x, m to m cancels. You can see x equals 2v. That velocity is 2v. That is greater than the velocity that was initially there at the same point before the explosion, right? So which means if there is u and 2v, the actual motion will be towards the direction in between. Now if this is what happens if there is no explosion, now with this velocity 2v, it travels further away. Sorry, it travels further away like this. It travels further away like this. So what's the answer? It should travel up and come back, right? Answer 4. Answer 4. It travels further away from the supposed point. For 23, answer 4. That's a good argument. So likewise, we can find these values, and direction of motion is in between. So it goes up and comes here. And since this velocity is a higher value compared to the initial velocity which had for the projectile motion, it travels away, more distance away from the supposed landing point. Right? 23, answer 4. 24. 24. Okay. Two thermodynamic processes, ABC and AC, of a closed system of an ideal gas are shown in the figure. In the process ABC, 6 kilojoules heat is absorbed by the system to go from A to B, and 1.8 kilojoules heat is absorbed from B to C. What is the change in internal energy in process AC? Okay, right. So this is what is given. Given PV is this. Given PV is this. ABC. Right. And this is 3 and 8. And here 2 and 5. Right. So given data are, first delta Q AB is given 6 kilojoules heat is absorbed by the system to go from A to B, which means delta Q AB equals 6 kilojoules plus 6 kilojoules because there is an absorption. Then delta Q BC is also given. Delta Q BC is 1.8 kilojoules absorption plus 1.8 kilojoules. Right. So we know this is a vertical line. In a vertical line, del W becomes 0. So del W AB is 0 because that is vertical, right? And yes, now knowing this, we can use first law in thermodynamics considering the process ABC. See, delta Q ABC can be written as delta U ABC plus delta W ABC. Delta Q ABC can be expanded as delta Q AB plus delta Q BC. Delta UABC can be written as delta UAC because internal energy depends only on starting point and end point, or the initial point and final point. Plus this can be expanded as delta WAB plus delta WBC. But we know delta WAB is 0. Delta WAB is 0. Delta WBC can be written as area under curve. Area under curve. Area under curve. Okay, delta QAB is here 6 plus here 1.8 equals delta UAC plus delta UBC here, area under curve. Area under curve is this area. This is the area under curve BC. That area is from here to here 8. Right? 8. 8 times, what's the value? 10 to the power 5. 10 to the power 5 plus this is 3. 3 times 10 to the power minus 3. 3 times 10 to the power minus 3. And this is in joules now. To make it kilojoules, 10 to the power minus 3 again. Right? This is 7.8 equals delta U AC plus 8 times 3, 24. 24 means that is 2.4. Right? 7.4 minus 7.8 minus 2.4 means 6. Sorry, 5.4, right? 5.4. Correct? 7.8 here minus this is 8 times 3 times total is 8. Yeah. 5.4. Delta UAC equals plus 5.4 kilojoules. Right? Now, even though 5.4 kilojoules are here as an answer, there was a mismatch in these given values. Now, if you apply the equation separately for like path by path, you will get different answers, negative answers actually. Right? So, therefore, in this year, question was given as an all question. This question was given as an all question. Now, even though we will get this, even though you get the answer, there are some mismatch in these answers if you use separately. So therefore, it was given as all, right? Otherwise, this can be done like this. Get the idea? It was given as all in that exam paper. 25. 25.25. 3-point charges plus 4q plus 3q and minus q are placed at vertices of an equilateral triangle of side length A as shown in the figure. The electric potential energy of the system is given by. Okay. These are the charges. These are the charges. Plus 3q minus q plus 4q. Distances are A, equilateral triangle. Right. So we know the theory is this. Theory is this. Electrical energy is written for two charges like this. Electrical energy is written for two charges as 1045 epsilon naught Q1 Q2 over R separation. This is the electrical energy for two charges, right? Now here we have three charges. So therefore, we can apply this equation 2 by 2. You can apply the equation 2 by 2. See? Now total energy, look at here. Total energy can be written as 1045 epsilon naught is common anyway. That is common, right? And when I multiply any two charges, Q and Q will be multiplied, right? Q and Q will be multiplied in all three cases. So therefore, Q squared is also going to be same, common. Q squared is common. And distance between any two charges is A. A is also common. So after taking everything out inside, now I can write the Q1, Q2 multiplication. And most importantly, since this is a scalar equation, scalar quantity, scalar equation, we have to plug values with polarities, with signs, right? First 2 plus 4 into plus 3. 4 times 3, right? Plus these two, 4 and minus 1. 4 times minus 1 plus the other two, 3 times minus 1. 3 times minus 1. Simplify this. 1 over 4 5 epsilon naught Q squared over A, and here 12 minus 4, 8 minus 3, can 5, right? So which means answer is 5q squared over 4 5 epsilon naught A. 5q squared, answer 1. For 25, answer 1. For 25, answer 1. 26. Okay. 26. A copper block is hung over a beak of water by a spring balance as shown in the figure. Consider the following positions while the beak of water is slowly raising upwards. Right. Position 1, the block is partially submerged. Position 2, the block is completely submerged. Position 3, the block is on the bottom surface of the beaker. Right, on the bottom surface. Right. Buoyant force is asked and reading of the balance is asked. Okay. Look at here. So we know if this is immersed like this and if this is hung from the spring balance, right? First thing, reading of a spring balance is tension, right? Reading of a spring balance is tension of the hook. That's the reading of the spring balance, tension of the hook, right? Now here the other forces acting are upthrust acts, mg acts, right? So therefore, considering the equilibrium of this, you can write u plus t equals mg, right? So which means t equals mg minus u. T equals mg minus u. And you all know that u is v rho g. U is v rho g. Now first one, when the block is partially submerged. If the block is partially submerged, some part of the volume is immersed. Right? Part of the volume is immersed. Second one, the block is completely submerged. Second scenario means the block is completely submerged like this. Right? So volume increases. When volume increases, this part increases. The subtracting part increases. When subtracting part increases, T decreases. Right? T decreases. So therefore, first reading is W1, right? So second reading decreases. Therefore, W1 should be greater than W2. And the third scenario is the block on the bottom. The block is on the bottom surface of beaker, right? The block is on the bottom surface. Before that, buoyant force is also asked, right? So about the buoyant force also we can argue from here, right? Same thing. U equals V rho G. Now, when it is submerged, V increases. When V increases, U decreases. Sorry, when V increases, U also increases. So therefore, at the first scenario, it's given as B1. It's given as B1. When it is submerged to this level, then this increases. And even though it hits the bottom, see, now third scenario is like this. Even though it hits the bottom, same volume is immersed. So therefore, at the third scenario also, it should be same as 2. Same volume is immersed. This volume and this immersed volume are same, right? Now it is done. B1 less than B2 equals B3. So we have two answers, 4 and 5. And about balance readings. Now when it is here, what happens is, now other than U and T, a reaction also comes from here, from the bottom surface. Because if it hits with the bottom, a reaction comes. Now with that reaction, tension will be further decreased. Why? Now if you write this equilibrium again, now what has happened is U plus T plus R equals mg. Right? Now nu T will be, let's say T dash will be mg minus U minus R. Now initially it was just mg minus U. Now that is mg minus U minus R. So T is further decreased. So therefore W3 is minimum. W3 is minimum. Right? So what's the correct pair? 5. For 26, answer 5. Hydrostatics. Right? Question from argument from hydrostatics. Okay. 27. The cross-sectional area of a uniform cylindrical metal rod is gradually reduced in part BC to form an object as shown in the figure. The object is perfectly lagged and the two ends of the object are maintained at temperatures 100 degrees Celsius and 20 degrees Celsius at the steady state. The variation of temperature theta along the axis L of the object is best represented by, right? So we know theta with L, theta with distance is given. That is the gradient of that given graph is delta theta over delta L. That is equivalent to gradient of temperature, right? So conduction, heat conduction equation is, we know Q over T equals Ka delta theta minus D, delta theta over D. Now in that case, delta theta is given as L, right? So therefore, now if I subject this, delta theta over L is given by Q over T over Ka, right? This is actually the gradient of graph. This is the gradient of graph. This is gradient of graph. That is the gradient. Now argue on the gradient. Now gradient depends on Q over T and K and A, right? Q over T on a single series combination of rods is a constant. So Q over T is a constant. Q over T is a constant. And K is also a constant. Now we have to build up our argument with area. You have to build up the argument with area. K is also constant, same material, right? Now, in the first part, we know area is higher. Area is higher, right? And from B to C, area decreases. So what happens when area decreases? Now, let's say this gradient is M. Now, finally, take out is this. Now, when area decreases, gradient increases. So it should be an increasing gradient. So we know increasing gradients are like this. These are the increasing gradients. These are negatively increasing gradient. Negatively increasing. So there is an increasing gradient. For the first part, there is a constant gradient. First part is a constant gradient, right? And the last part from C to D is the least area. So lesser the area, higher the gradient. Lesser the area, higher the gradient. Higher the area, lesser the gradient. Now compared to AB, CD is less in area, so it should be higher in gradient. Higher gradient means that's a higher slope. Higher gradient means higher slope. So this basic shape is there in 4. For 27, answer 4. Answer 4. This is the argument. Twenty-eight. 3 small conducting spheres carrying charges plus Q, minus Q, and plus Q are located at the vertices of an equilateral triangle ABC, situated on a frictionless horizontal surface as shown in the figure. The spheres at B and C are fixed, and the spheres at A is free to move. The possible path of sphere at C is best represented by, okay. This is B minus Q, B minus Q. This is C plus Q, right? And the top one, A plus Q, right? So we know when it comes to Coulomb force between static charges, if they are homogeneous charges, homogeneous means same charges, they are repulsive forces. And if they are opposite charges, they will be attraction forces, right? Now, if I mark the force first, between plus and plus repulsions, the force is towards this. Between plus and minus attractions, the force is towards this, right? Now, if you check these forces are equal in magnitude because charges are also same, distance is also same, because according to Coulomb's law, F is given by 1/4 epsilon naught Q1 Q2 over R squared. Coulomb's law, right? If charges are same and if the distance in between are same, these two forces are same, right? And since there is an equilateral triangle, these angles are 30 and 30, right? Now here upwards you have F cos 30 and downwards also F cos 30. So these two cancels each other. And towards this direction, from here F sin 30 comes, this will be 2F sine 30. 2F sine 30. So with that force, it starts to move to the left. With that force, it starts to move to the left. And now towards left also, to check the exact path, I'm going to check the variation of force again after a while, after a little while. Now let's say, now from here to here, it moves. Now it is getting closer to this one, while it is getting away from this one, right? So when it's getting closer, when this distance increases, force increases. So therefore, when it's moving forward, the force due to minus q here, B, force due to minus q, B here increases. When that force increases, this will be tending towards this direction because this force increases, the distance decreases. So therefore, answer is C. Answer C, 28, answer 3. Right? Good argument. A good argument. 29. 29. Okay. It says, as shown in the figure, a conducting loop is placed perpendicular to a uniform increasing magnetic field. Which of the following graphs best represent the variation of magnitude of induced EMF E in the loop with the rate of change of magnetic flux density R? Okay. So we know, according to Faraday's laws, right, induced EMF is given by E is given by delta band over T. Right? Now it says the rate of change of magnetic flux density is R. So I'm going to isolate that term. So this means this is delta B over T, rate of change of magnetic flux, times AN. This is given as R. So which means this is R now. R times AN. So build up the equation. E equals AN times R. Right? R is as X. A is area of loop. That's a constant. N is number of turns of the loop. That's a constant. So therefore, this is a constant gradient. Equals, this is Y. So the graph is Y equals mx. Answer 5. Y equals mx. Answer 5. For 29, 5. For 29, answer 5. 30. 30. Okay. An object of mass m, stationary, at time t equals 0 is subjected to a force F directed along a straight line that varies with time t as shown in the graph. Select the correct statement from the followings. After the motion has started, the velocity of the object becomes 0 at several answers are given. Okay. A FT graph. Right. So FT graphs are very popular in our LL paper. Right. FT graphs are very popular when it comes to our paper. Right. 8 minus 8. 40. 60, 80. 60, 80. 100. 120. This is also at 8. 120. Right. So first thing is area of FT. Area of FT gives delta MV. Right. Area of FT graph. Area of FT graph gives change of linear momentum. Change of linear momentum. Right. That we discussed under linear momentum usually. Right. So area of FT graph is F times T. Right. So therefore, area of FT is change of momentum delta MV. Area of FT. Right. Area of FT is delta MV. Right. Now, first I'm going to check. It says it's starting from rest. An object of mass m stationary at time t equals 0, starting at rest. Right? I'm going to check the velocity of the object after 40. Right? If I need to get the velocity, now we know area under this part will be change of linear momentum up to 40 seconds. Right? So up to 40 seconds, if we apply, look at here, up to 40 seconds for this triangle, up to 40 seconds, area is half times. Let's consider mass of the object as m, half times. This is 40 times 8 equals delta mv. If there is initially at rest, there's no initial linear momentum. So it equals to final linear momentum at once, mv. So if this is simplified to 20, which means 160 equals mv. For v, we have a value here, 160 over m. Right? So which means at 40, there is a velocity. Because m is an non-zero value. Since m is a non-zero value, velocity at this point is 160 over m, that is non-zero. Right? Now, my argument is this. If this is moving in the negative side, not moving in the negative side, actually the force is applied to the opposite side. If the graph is at negative side, so we know there is a possibility of cancelling these two and becoming a velocity 0. Right? There's a possibility. So therefore, first I'm going to check the check the area of this trapezium. Right? Now, as the second one, let's check the area of this trapezium. This one. Right? If that is checked, that will be 40 to 160 plus this part is 20 over 2 into perpendicular distance 8 equals mv again, equals delta mv of that part again, mv again. Right? Now this is 60 plus 20 is 80, 80 over 4 is 80 over 2 is 40. 40 times 8 equals mv. Right. Which means this velocity is let's say v dash, this velocity is 320 over m. Now it's very clear that this is 2 times of this value, 160 over m, this is 320 over m, which means exactly at the midpoint of this, exactly at the midpoint here, exactly at the midpoint, this area should be equal to, half of this value, 160 over m. Right? Which means now this is 160 over m momentum change in positive side, and this is 160 over m momentum change in negative side. These two cancels each other. When it cancels, velocity becomes 0. So therefore, if this is 60 and 80, this is 70. So at 70 exactly, velocity becomes 0. Now we have determined one point already. So at t equals 70, velocity becomes 0 because these two cancels each other. This one to this one cancels because this is also 160 over m. This is also 160 over m. This is also 160 over m minus these two cancels. And at 70, velocity becomes 0. Right? Now it will become 0 again if these two areas are equal only. It will become 0 again if these two areas are equal only. Now never going to be same because now if needed you can calculate, but just by looking at that also we can say they are not going to be same, right? Because these two parts are same already, ne? Yeah, 20 and 8, ne? Yeah, these two parts are same already. Look at here. Since these two parts are same, right? Now this total area is never going to be equal to this total area is never going to be equal to that. So which means this setup is never becoming 0 again. This setup is never becoming 0 again. Got it? The setup is never becoming 0 again, which means it is only at t equals 70. Only at t equals 70. Answer 2. For 30, answer 2. That's a good question. Good argument. Right? So at t equals 70 seconds. At t equals 7 seconds. Right. Okay. Okay. Right. So now we have discussed up to 30th MCQ of 2020 physics paper, past paper, 2020 past paper, and I'll be keeping the remaining 20 questions to be discussed with another discussion on a different day, right? And definitely we'll be discussing the full paper, and this is actually the part 1, and up to 30th MCQ we discussed today. Part 1 and up to the 30th MCQ only we discussed today, and the remaining 20 MCQs will be discussed on a different day, and you can get all updates through my channels and groups, Telegram channels, WhatsApp channels and groups. Stay connected with them. We'll be discussing the rest in another session on a different day, and my plan is to discuss other past papers also. Now we started last week from 19, and today we discussed 20. Likewise 20, 21, 23, 24 up to 24 we'll be discussing these ones in a weekly basis, right? Most probably this session will be on Wednesdays, right? So last week also we had the session on Wednesday, right? For remaining 20 questions I'll be allocating another day, and you can get all updates through my channels, right? So therefore stay connected, and let's join with the next discussion. I'll be informing you all the details regarding the next discussion through the channels and groups, right? Okay, so I hope you got something out of this with the discussion. Now this is the 11th week going on before the exam, ahead of the exam. So please work hard and study hard, and I highly believe that you can get maximum out of these discussion reviews. If you are facing A levels 25 especially, or it doesn't matter whether you are 26 or 27 or whatever it is, past papers will be past papers always. So therefore any student who is watching this can take this benefit, right? So if you are in the live until this point, and if you have understood everything we discussed today, put a comment after the live session is ended, because then only the comment will be retained on YouTube. Put a comment whether you understood these parts or not, right? So if it's clear, put a comment as it's clear, and if you have doubts also, just tell me if you got any doubts, then I can reply later once I saw your comments, right? Okay then, so let's meet with the next discussion on the next week, in the next week. So until then, goodbye. Let's meet with another discussion in next week, right? Good night and goodbye.